graph of this function, e to the xy minus y equals 2, when we sketch this graph, the graph of this is going to look something like this. It's going to looks like it has a horizontal asymptote here. It kind of crosses through there, and it looks like it has another horizontal asymptote here. So the point that we're looking at is when y equals 2, we want to know the equation, the slope at that point in the equation of the tangent line. So we want to find the equation of this line right there. So to do that, we need a derivative. So we're going to differentiate this. So we have to differentiate, since it's an implicit function, we need to differentiate implicitly. So differentiating the outside, chain rule, I'm going to need to apply the chain rule here to differentiate the inside. And as I differentiate the inside, I have to apply product rule. Here I need to differentiate y to y prime, and that's equal to 0. Expanding this out, I end up with y times e to the xy plus x e to the xy times y prime minus y prime. Group together the y primes. So this is x e to the xy minus 1. And then I can move that other term to the other side. This becomes negative y e to the xy. Solving for y prime, I end up with negative y e xy over e to the x e to the xy minus 1. Get rid of the negative, make this into y e to the xy, and then switch the denominator around. Okay, so either one of these will be fine to calculate the derivative. So I need to calculate the derivative. So I've got the derivative here. So I need to calculate the derivative at y equals 2. That means then I need to know what x is equal to. So I have to solve for x. So to solve for x, I'm going to take that original equation. I'm going to substitute in y equals 2. And then I'm going to solve this equation. So e to the 2x is equal to 4. I can square root both sides here, so I end up with e to the x is equal to 2. X is equal to log 2. So there's my x coordinate. There's my y coordinate. So to calculate the slope, I plug those back into the equation. So x equals log 2, y equals 2. So my equation is going to be, so my slope value works out to be 2 times e to the 2 log 2 over 1 minus log 2 e to the 2 log 2. Okay, working this out, 2 log 2, this should be log 4. I'll maybe do it in steps here. E to the log 4, which is, that expression is just going to be equal to 4. 1 minus log 2 times e to the log 4. Okay, so this becomes 2 times, that just becomes 4. 1 minus log 2, and that just becomes 4. So the slope value is 8 over 1 minus 4 log 2. So there's my slope. To calculate the equation of the tangent line, I need to plug in my x and y and my slope into my point slope form. There's my slope. X minus log 2 plus y is 2. So there's the equation of my tangent line. Okay, so I differentiated implicitly, calculated my, found my derivative, calculated x by substituting 2 into my original function. Once I have my x and y, I plugged it into my derivative to calculate slope, and using the slope and the x and y coordinate, we got the equation of the tangent line.